Namaste and warm welcome to everyone. This presentation is titled Understanding P-Value and Alpha Value, Simplified Concept. I am Anjil Hada, currently pursuing my Masters in Educational Mathematics at Kathmandu University. This session has been prepared as the part of our course and under the guidance of our respected course facilitator, Mitra Kumar Manandar. In this short session, we will explore the key idea behind p-value and alpha value in hypothesis testing, broken down into simpler and practical terms. Here's what we'll be covering in today's sessions. First, we'll introduce the concept of hypothesis testing. Then we will understand what p-value is and what an alpha value represents. We'll look at how these two are related. We'll go through examples and interpretations. A visual table will help reinforce the concept. We'll address some common misconceptions, and finally we'll summarize the key takeaway and provide references. So let's dive into the first concept. Hypothesis testing is a method used to decide whether there is enough evidence in a sample to support a certain belief or claim about a population. To make it simple, imagine you are guessing whether a coin is fair. You flip it many times and use the outcome to test your guess. That process of making a claim and checking it using data is what we call hypothesis testing. Now let's understand what the p-value is. A p-value is the probability of getting a result as extreme as one we observed, assuming that the null hypothesis is true. A small p-value tells us that what we observe is quite unlikely under the assumption of the null hypothesis. Here's a simple formula for p-value in the slide. In short, p-value tells us how surprising our result is. For example, if we flip a coin 10 times and get 9 heads, the p-value helps us measure how likely that is if the coin is truly fair. Next, we come to the alpha value, often written as alpha in Greek symbol. Alpha is the threshold or cutoff that we set before testing. It tells us how much risk we are willing to take in wrongly rejecting a true null hypothesis. Common alpha values are 0.05 or that is 5% and similarly 1% or 10%. To put it simply, alpha is the rule we set to say if something is unusual. So if we set alpha equals to 0.05, we are saying I'm okay with being wrong 5% of the time when I say something is statistically significant. Now, how do p-value and alpha value work together? Here's how we compare them. It's shown in the table. So a simple way to remember this is if p is low or p-value is low, we say no to the null hypothesis. That means if the p-value is less than alpha, we reject the null hypothesis and consider the result statistically significant. Now let's see how this works with example. Suppose we are testing a new medicine. Null hypothesis in this case will be the medicine does not work. Let's say we get a p-value of 0.03, that is 3%, and our alpha value is 0.05%. Since 0.03 is less than 0.05, we reject the null hypothesis. So what is the interpretation here? That is, there is only 3% chance we would get this result if the medicine did not actually work. So we say it likely does work. In simple terms, if the chances is very small, well, we believe something is really happening. Here is a visual summary of how different p-value affect our decisions. So in this table, the different value of p is given in the first column and similar to the decision in the second column with what it actually means in the third column. So key idea here is lower the p value, stronger the signal, or smaller p value means stronger evidence against null hypothesis. Let's now clear up a few common misconceptions. A p-value is not the probability that the null hypothesis is true. A small p-value does not prove that the alternative hypothesis is correct. Alpha is not the chance of making a correct decision. So, remember, p-value is about results, not truth. It tells us how rare or extreme the result is under assumptions that null hypothesis is true. Here's a quick summary of what we learned. The p-value tells us how unusual or extreme a result is if null hypothesis were true. The alpha value is the threshold we set to decide whether the result is significant. We compare p-value and alpha value to decide whether to reject the null hypothesis. In short, we compare surprises that is p-value to our rule that is alpha to decide. That's the extent of hypothesis testing in practice. So these are the key references used in preparing the presentation. They are great resources if you want to explore further. By this, we come to the end of our presentation. Thank you so much for watching this presentation. Thank you all.